Straight from South Africa. This is the strange and mysterious world with your hosts, Lee Stratum and William Collinson.
Cool. And welcome to Strange and Mysterious World. This is season 1, episode 15. Well, I think this is going to be a good one today. We are interviewing Professor Avi Loeb, all the way from the US of A.
Nice, man. I'm really looking forward to this, Lee.
Yeah, I've heard a couple of Avi's interviews and things, and I want to change it up a little bit. I want to change it up because everybody keeps asking the same questions. And every time you link on, it's the same stuff that they keep asking him. So I want to get in a little bit deeper into other stuff, man. The things that we talk about, strange and mysterious. So let's go from there, bud.
Okay, cool.
So how is he ready? Is he ready?
Hasn't said anything yet. Do you want to do like introduction on him or something? Or
yeah. Well, look, I'll probably let him do the introduction. Shalom Aleichem, Avi.
Not bad. I don't know how to say it in other languages, though. Where did you learn that?
Well, I've got a lot of. I've got a couple of Jewish friends, and I've got a lot of Muslim friends. So the Muslim and the Jewish is very similar.
Yeah, they are. Did you know? Well, I can tell you an anecdote. I was in the women's forum, international forum in Las Vegas, and one woman came to me and said that I have 800 scientists, women scientists in Iran,
okay,
who are following my work. And just think about it. I'm originally from Israel, they're from Iran, and there are 800 women following my work based on social media. So
what does your wife think of that?
My wife?
Yeah, what does she think of 800 women following you?
She said, take an extra day, enjoy it. I mean, she is not worried about, by now, she knows me well enough. Either she's not worried or she wants me to leave. I mean, these are the two explanations.
Awesome. No, fantastic. Avi, thank you very much for coming on board, man. Like I said previously, we're very casual on this side. We try and, we make people feel as comfortable as possible. A lot of our listeners actually comment on how funny sometimes the podcasts are, which is, we want to try and keep things light-hearted and and those kind of things. So just a quick one.
Ask me anything. Don't hesitate.
Don't hold back, man. Mm-hmm. All right. So a little bit about yourself, Avi. I know you grew up on a farm. I know that.
Right. So I'm a farm boy. I used to collect eggs every afternoon when I was young, and very much connected to nature. So I used to drive a tractor to the hills of the village and read philosophy books. I was mostly interested in French philosophers, existentialists like Jean-Paul Sartre, Albert Camus. And what attracted me is the fact that they are sincere, that they do not pretend to be someone else. And what was frustrating to me as a kid was going to the dinner table and asking a difficult question, and then the adults in the room would dismiss it simply because they didn't know the answer. And I felt that by becoming a scientist, I can answer the question myself. And actually, just a month ago, I visited the elementary school where I went to as a young kid, which is very close to my home. The home where I grew up. So I told the kids, I'm just like you. I mean, I'm curious, I'm wondering, and I don't pretend to know something that I have no clue about. And they said, one of them said, how can you be a kid? You are 61 years old, And I said, well, it's not a matter of biological age. It's just, it's a question of maintaining a beginner's mind. So if you are curious about the world and you don't pretend to know more than you actually know, you are a kid.
Yeah, 100%. I agree with that. You know what? It's actually, I was chatting to Will a little bit earlier. It's nice to have someone in the scientific community that is on our side of the fence. it's so hard when when you're chatting to scientists to try and bring these topics up, because it's just, it's a one-way traffic.
Well, there are two reasons for that. One, many of the scientists are sort of nerds. They're highly accomplished professionally, and they're highly capable technically, writing equations, solving them, using the computers, and they're not good at communicating with other human beings. That's part of it. And you can understand that that's true of other professions as well, where people specialize and they're not necessarily good communicators. That's one aspect. But the other aspect is that as part of, when people go to academia, they get attached to their ego, because it's all about demonstrating that you are smarter than other people. And then, in a way, it's just like athletes. They run the 100 meters dash simply in order to demonstrate that they're doing it better than other athletes, or they can set the world record. Running the 100-meter dash doesn't solve any existential problem for humanity. It doesn't help anyone. It's just showing that you can do it better than others. And some people view academia as a tool to demonstrate that they're smarter than others. Okay, so, and I've seen throughout the 40 years that I practice science, a lot of people, even the most accomplished ones, they just use it as an ego boost. And they just get more and more attached to their self-esteem and the sense of accomplishment. So they do it in order to get honors, awards, recognition. And then they view the public as a community of people who are not professionals. They're not even in their league. They will never be able to understand. I don't need to impress them. I don't need to communicate with them. And in fact, they feel superior relative to the general public. And that's very unfortunate. Why is it unfortunate? Because the public pays taxes to support science. The public cares about very important questions. For example, are we alone in our cosmic neighborhood? Is there someone else out there? And then the scientists can say, well, I don't want to deal with that. I just want to do some mathematical gymnastics that demonstrates that I'm smart. I just want to work on the multiverse, on extra dimensions in string theory. And then I will show that I'm smart. But the fact that the public doesn't care about it, or at least it doesn't affect the future of humanity, is completely irrelevant. So this sense of arrogance, I think, is completely inappropriate. And because I came from a farm, I feel that I'm not superior relative to anyone else, that I feel as part of the public, and I feel curious about questions that the public feels curious about. And also, I feel it's my duty to converse with the public, because I'm no different. And in fact, I don't want to pretend that I know the answers to questions that the public cares about. It's not true. We don't know the answer whether we are alone, and let's find out the answer because the public cares about it. And so, I'm very uncomfortable with this state of affairs. And one reason that I communicate with the public is that I have no sense of separation. And I do believe that we should engage as scientists in questions that could impact the future of humanity.
Okay, so now let me ask you something. Why astrophysics? You had a whole field to go in, so why astrophysics?
Yeah, so for me, it was just circumstances, because I grew up in Israel, and serving in the military is obligatory. So I wanted to do something that is closest to philosophy, which is physics and mathematics, which I was allowed to pursue in a special program within the Israeli military. And as a result, I finished my PhD in physics at age 24. And then I was offered a position at Princeton, the Institute for Advanced Study, where Einstein used to be faculty. But it was under a condition that I'll switch to astrophysics. And I said, okay, well, I'll do that. I didn't know how the sun shines. I didn't know anything. So I started learning. And then they offered me a position at Harvard. And I said, okay, well, I cannot refuse that as well. And then I got tenured at Harvard. But at that point, I realized that I'm actually blessed because I'm married to my true love, even though it was an arranged marriage. I didn't choose to become a scientist. The circumstances forced me, because now I can ask big questions that are in the realm of astrophysics that used to be philosophical originally, but now we can address them scientifically. Like, for example, how did the universe start? What was there at the beginning? So I started working on, the first stars, the first galaxies, how the first light was produced in the universe, which is, part of the story of Genesis in the Old Testament, in the Bible. And now we have scientific understanding of what may have happened. And I worked on that before many people did. I was among the pioneers of this frontier. I wrote two textbooks about it. And now the Webb telescope that was launched a couple of years ago is able to see the first generation of galaxies and address that. And then now, more recently, I started working on the question. I also worked on black holes in the meantime, but now I'm primarily interested in whether there is another intelligent civilization out there that we can learn from. That will be an opportunity for us to learn. And again, it's it's a sense of humility that must come from observing the universe, because we are not at the center of the universe. We just came at the end of the cosmic history. And, if you come to a play and you're not on the center of stage, the simplest conclusion is the play is not about you. So we tend to think everything is about us. But here is the breaking news. It's not about us. Even if we are visited by aliens, they must have started the journey long before we came to exist as the human species. So just forget about this sense of self-importance. I started by saying that in academia, many scientists have a sense of self-importance. But as humans, we also tend to think that we are very important and that we are at the center of all the attention in the universe. And I say, no, don't forget about that. I mean, I can understand where it's coming from, because my daughters, when they were young, they thought the world centers on them. And there was a reason for that, because all they saw is people paying attention to what they do. So they thought they are the center. But of course, by now, some 20 years later, they realize that the world is much bigger than the environment. And for us as humanity, it also started that way. We only knew what is happening to us, so we thought we are at the center. But now I say, we know much more about the universe. Let's forget about us. It's not about us.
So it's basically about people climbing out of Plato's cave, hey, William?
Climbing out of what?
Plato's cave.
Oh, yeah. I mean, I use the allegory, the cave allegory of Plato, where you have prisoners in a cave looking, they're chained, so they can only look at the wall in front of them, and they see shadows of things behind them and trying to conclude what these shadows mean. And so, if we ever encounter gadgets from other civilizations that come to Earth and visit us, it will be sort of the shadows. We will not necessarily see the senders of these gadgets, these spacecraft. We will just see the spacecraft and sort of like the shadows trying to infer what lies behind them. Like what is the nature of those senders? So I do like Plato's allegory of the cave, but I apply it in the context of us encountering something from another civilization.
Avi, I want to take you back, like right back to your childhood. What were your thoughts on extraterrestrial life? Did you think something was ever out there at that age, or was it only at a later stage that you thought, geez, maybe there should be something out there? Was it early later?
I didn't think about that. And I should say that most of my life, I didn't like science fiction, because it always bothered me as a physicist to watch these stories that violate the laws of physics. Because they go faster than light. The storyline often talks about relatively short journeys to nearby stars, and I know that it takes a huge amount of time. For example, with the current spacecraft that we are launching with rockets, it would take about 50,000 years to reach the nearest star, Proxima Centauri, which is 4 light years away.
Yeah.
And 50,000 years is the time that elapsed since the first humans left Africa That's a long time.
Yeah.
So if we were to send a spacecraft back then, when the first humans left Africa, it would only reach right now the nearest star. So that would be a very boring storyline for a science fiction story, because there will be so many generations on the ship where nothing really happens except they just travel through darkness. And so, of course, any author of science fiction doesn't want that, and they invent all kinds of storylines that make no sense. So that's why I didn't enjoy science fiction. But then, about 6 years ago, there was an object discovered in October 2017 by a telescope in Hawaii that came from outside the solar system. And it looked very different than the rocks that we are familiar with. And so I contemplated the possibility that maybe it's a product of technology by another civilization. And that's what brought me to the subject. It's more about, the fact that we now see interstellar objects that came from outside the solar system and they look weird. There was another one that was a meteor from 2014, discovered by US government satellites and about a decade ago. Again, it looked very unusual. So for me, it's just, having this evidence about the first interstellar objects that made me very curious. Maybe we are being visited.
Okay, well, that's great. Now, I want to ask you something, because I'm assuming you were talking about Oumuamua, the
Yes,
object that was
the
discovered.
first.
So there's a couple of things I want to find out. The first thing is, excuse me, how on earth did we almost miss this 400-meter object going past us? I mean, surely we've got stations on Earth and in the sky that's able to detect certain things. How did we miss this?
Well, okay,
Almost
so
miss it.
you need to understand the mindset of astronomers. Astronomers were seeing rocks from the solar system for many decades, centuries. Okay, so they assumed that anything we would see would be from the solar system, and therefore we are familiar with rocks. There is nothing that makes them particularly exciting, but nevertheless, what the most important reason that the telescope was put in Hawaii, this observatory called Pan-STARRS, was that in 2005 the US Congress gave NASA a task to find 90% of all near Earth objects. They are called these are objects that come close enough to Earth to potentially collide with Earth and hurt us. And they asked to find all of them that are bigger than the size of a football field, about 140 meters. So that was the task given to NASA, and that's why the Pan-STARRS telescope was constructed in Hawaii, to look for such objects, near Earth objects. And then it was basically flagging every object that comes close enough to Earth. And this one, Oumuamua, was one of them. It wouldn't be flagged if it were to pass very far from Earth, and we would just miss it. And I'm sure we did miss some of them. But simply, this one came within a sixth of the Earth-Sun separation. So the operators of the telescope realized, oh, here is a near-Earth object. They flagged it, and then they measured the speed of this object and said, wow, look at that. It looks like this object is moving faster than the escape speed from the solar system. So in other words, it's not bound by gravity to the sun. It's moving too fast. And so it means that it came from outside the solar system. So that was a complete coincidence. Just because it came close to Earth, they noticed it. And you would say, okay, well, after that, obviously the astronomers will go and look for all the other interstellar objects. Well, there is a new telescope in Chile called the Rubin Observatory that is expected to start operations in a year, 2025. It cost about $600 million to construct, to build, and the data will be public. It was funded by the National Science Foundation in the US. So you would assume, okay, given that Oumuamua was discovered, of course, astronomers will define as a high priority finding other interstellar objects. And if you do the calculation, you find, well, it should find, because it's much more sensitive, it will use a camera with 3.2 billion pixels, 1,000 times more pixels than your cell phone camera. And it will survey the southern sky every 4 days. You would think, that obviously it will be very sensitive. It could actually detect an Oumuamua-like object every month, okay? But a year ago, I asked those involved in the project, the Rubin Observatory, and I realized that nobody is looking for interstellar objects. Actually, the software used by people who plan to process the data will only look for objects that are bound to the sun in terms of objects passing near Earth, and not for anything outside of the solar system. And I said, how is that possible? So then with my postdoc, we developed the software that will search for interstellar objects. And the hope is that we will find many of them, maybe a dozen a year. And that will allow us to follow up and figure out what they are. Even if 1 out of 100 happens to be technological in origin, not a rock, that would be similar to finding a tennis ball in your backyard, among all the rocks that you see. And it will inform you that there is a neighbor that threw this tennis ball. So that would be an amazing discovery, and we hope to do that. But since then, we also, with my student, we also found a meteor from 2014 that I mentioned, the first interstellar meteor, an object roughly the size of a watermelon that collided with Earth a decade ago and created a fireball as a result of its friction in air. And the US government satellite detected it and measured a very high speed that we interpreted to mean that it came from outside the solar system. And actually, half a year ago, I went in summer 2023, between June 14th to 28th, we went on an expedition to the Pacific Ocean to search for the materials of this meteor. And we are about to finish now the analysis. And it looks like we discovered some materials that have a composition of elements different from what's known about material from the solar system.
Okay, that's awesome.
Nice.
One more question on Oumuamua. Your data said something very different to what we've been seeing as the general public. I mean, the general public, we've been shown Oumuamua as a cigar-shaped object, but your data shows something completely different. So why have they pushed that agenda? What do you think is the issue?
No, so originally, I mean, we don't have an image of Oumuamua because it was too small to resolve with even the biggest telescopes. But what we did know immediately is that as the object tumbles every 8 hours, the amount of sunlight that is reflected from it changes by a factor of 10. And so that means the area of the object projected on the sky is changing by a factor of 10 as the object is spinning. And think about a piece of paper, that when it is tumbling in the wind, you see a different amount of area of the piece of paper in front of you. And change by a factor of 10 means that the object has a very extreme geometry, similar to a piece of paper. Now, when you look at a piece of paper and it's, sort of close to being edge on, it looks like a cigar. It looks elongated. So that's what the artist illustration was, that basically tries to show an object that is 10 times longer than it is wide. Project.
Okay, so we're seeing the Sidon project.
Yeah, but in fact, there was a very detailed paper analyzing the light curve, the amount of light as a function of time reflected from the object, and concluded that the 90% confidence that this object must have been flat. And even the original discovery paper suggested that it's most likely flat. And for some reason, the artist ignored it. And then everyone, all the reporters were showing that artist's illustration. But the correct way to think of this is it was most likely flat, like a pancake. But when you look at it sideways, it looks like a cigar.
Okay. All right, I understand that. Your thoughts on, okay, so planet Earth, the guys, there's a lot of research going on, especially on land. Under the sea, not too much. We've got a lot of research going on in space, which is cool.
Mhm.
What are your thoughts on researching extraterrestrial objects that are on Earth and can be detected on Earth? So under the water, in the mountains, because we always hear that, when we get these UFO reports that come from people, they're always saying things that are like, for example, the Nimitz, they were saying things were coming from the water. There's people that are saying things that are coming from the mountains. So what is the possibility of detecting extraterrestrial technologies that are actually here on Earth?
Yeah, I think, well, first of all, from an astronomer point of view, from a scientist point of view, it's much cheaper to study things on Earth. I mean, just to give an example, if we want to get materials from an interstellar object like Oumuamua, that means designing a space mission that would, chase it, land on it, retrieve some material, and then bring it back to Earth. That will cost more than $1 billion. I mean, we've done it with OSIRIS-REx that went to the asteroid Bennu, and they brought eventually some material to Earth. But it's a very expensive mission. The expedition that we had to the Pacific Ocean cost us $1.5 million. So that's a factor of 1,000 less money. And in fact, it's so much easier that you can do 1,000 expeditions for the price of one OSIRIS-REx like mission. And I should say OSIRIS-REx had an easy job because the asteroid that it was after was moving relatively slowly compared to the spacecraft. But if you consider interstellar objects, they move very fast, and chasing them is not easy, okay, or colliding with them. So I think it's a much more promising path to explore by looking for interstellar objects that became meteors. In other words, collided with Earth, generated a fireball. You can go after them. And you know that they are interstellar because you measure their speed before they collided with Earth, and you can infer that they were moving too fast to be bound to the sun. Another possibility is, of course, just like the Nimitz that you mentioned, you see functional devices that humans may have not produced. And again, it's easier because it's closer to us. We just need to be at the right place at the right time. And that's why I'm leading the Galileo project that is now operating an observatory at Harvard University. We're monitoring the sky 24/7 in the optical, infrared, radio, and audio. And we hope to see some unidentified anomalous phenomena, the way the US government talks about, and intelligence agencies, military personnel. So we are trying to find such objects. And it would be fantastic if we were to visit a crash site, if we could find some materials. For now, the only materials that I was able to retrieve was from the crash site of the meteor, the interstellar meteor that we went after. So the answer to your question is definitely yes. I do see that as a very important, and in fact, the most practical way of learning about things that came from outside the solar system.
Do you get government funding for that stuff, or is it still going to be privatized?
No, it's all based on donations.
Yeah.
The issue with, okay, so to get government funding, you often need to submit proposals to federal agencies like the National Science Foundation, NASA, and the committees that evaluate those funding requests are often filled with people who work in the mainstream of science that are not necessarily asking those questions, and they regard those questions as risky. And in fact, it's very difficult to get funding through those channels. I did not actually engage in fundraising. People just read my book, Extraterrestrial, in 2021, and provided me with a few $1 million for the research of the Galileo project. They just contacted me, and now I have a second book out called Interstellar, and I also write routinely on medium.com. You can find my essays every day or two These are updates about my work. You can find them by searching for Avi Loeb at medium.com. Subscription is at no cost whatsoever. You can get updates. So I have a lot of visibility, and as a result, wealthy individuals decide to fund the research. And of course, in the case of Galileo, the Galileo project, the more funding we get, the more observatories we can build around the world that we look for anomalous phenomena. And we now know how to build such an observatory because we have a successful one at Harvard. And so anyone interested in promoting this research and even having an observatory called after them in their favorite location just need to contact me.
Okay, that's awesome. I think it's actually better the government stays out of it. Because as you said, I think they ask too many. They one trap mind, and if you do find something, they would expect it to be quietened down. They wouldn't want you to release it to anyone.
So exactly. So with the so the interesting question is whether the government has its own data, because there were some people who said that, especially David Grush, a whistleblower that gave a testimony in the House of Representatives and in the U.S. and under oath, and claimed that the U.S. government has programs for retrieval and reverse engineering of materials that were collected from crash sites of spacecraft that came from outside of this Earth. And so the issue is that these are, according to him, classified programs. We can't get access to the information. Of course, from my perspective, if the government has any such data, it should reveal it. It should share it with scientists. It would save me decades of my own time if they already found the materials or the evidence. And it makes no sense for them to keep it because it's not a matter of national security. You know, anything that came from outside the solar system should be, of interest to all humans, and nothing in particular attending to the interest of one nation or one government. So my hope is that someone in government will see the light and release any such information if it exists. I don't know if it exists because I've never seen it.
Okay, no, that's awesome. And then I know you lead the Black Hole Initiative. So, how have you guys detected any in our neighborhood, black holes?
Yeah. So in fact, the Black Hole Initiative that I founded, I was the founding director of, started in 2016, and it was a center that brought together astronomers, physicists, mathematicians, and philosophers. And in 2019, 3 years later, the first image of a black hole was actually derived from data at the conference room of the Black Hole Initiative, and it got to the press. It was a very famous discovery. We have a photograph of a black hole. The shadow of the black hole is seen as a dark region on the background of hot gas that is swirling it. And since then, there was another image obtained for another black hole. So the two black holes are one in a galaxy that is a very massive galaxy called M87 in a nearby cluster of galaxies called the Virgo cluster. It's about, and the second one is in the center of the Milky Way galaxy, our own galaxy. The first one is 2,000 times farther, but also the black hole is 2,000 times bigger in mass, so or 1,500 times bigger in mass. So then on the sky, the black hole size is proportional to its mass, so it's actually projected to be roughly of the same size on our sky, the two black holes. And one of them is about 6 billion times the mass of the sun. That's in M87. And the other one is about 4 million times the mass of the sun at the center of the Milky Way galaxy. And now we have these two images. So we know that black holes exist. And of course, there was an important discovery in parallel to that, which is the detection of gravitational waves, which are ripples in space-time from the collision of black holes at the edge of the universe by the LIGO experiment, and it won the Nobel Prize. So we now know that black holes are real, and they're really amazing objects because they are just extreme distortions of space and time. And if you end up inside the event horizon of a black hole, it's the ultimate prison. You can never check out. Even light cannot escape from there. So sort of a one-way street if you end up there. A small black hole, roughly the mass of the sun, or a few times the mass of the sun, up to 100 times the mass of the sun. These black holes are generated by the collapse of the core of a massive star. And these black holes are very harmful. If you are an astronaut and you approach such a black hole, then your body would be ripped apart as you get close to the black hole, even within the event horizon distance. The other type of black holes are very massive black holes that form at the centers of galaxies. And as I said, there are millions to billion times the mass of the sun. And those, if you were to enter the event horizon, you wouldn't feel it, because the difference in force between the different acceleration on your toes versus your head will not be significant. So you will just fall as a whole, as a piece through that event horizon. Nothing bad will happen. And then it will take you a few hours to a few days until you end up very close to the center of the black hole, where your body would be ripped apart by the singularity there. So, so it's not a pleasant journey at the end in both cases, but at least for the most massive black holes, you can have a journey for 4 days, falling at almost the speed of light towards the center of the black hole, and you can still enjoy it for most of the time for those massive black holes.
So let me ask you a question on the black hole. So everything gets sucked into the black hole, even light.
Right.
Where is it going? Do you have a theory? Because there's something, somebody has mentioned, or I can't remember, there are theories that would talk about something called a white hole, where the reverse is actually happening of a black hole.
Well, that's just a mathematical curiosity that, but the thing is that Einstein's equations, which are used to describe a black hole, based on the way he basically identified gravity with curvature of space and time and wrote the equations that describe it. Those equations break down when you get close to the center of a black hole, because the curvature of space and time becomes infinite. It diverges, and then the equations cannot work. And you don't know what happens near the center of a black hole. So that's called the singularity. And we know why there is this shortcoming of Einstein's equations. It's because when you get to very high curvatures of space and time, quantum mechanics should be important. And quantum mechanics is another pillar of modern physics. However, we don't have a theory that unifies quantum mechanics with Einstein's gravity, with the general theory of relativity. So we don't know what happens in the center. I think my view is that all the matter that falls into a black hole ends up making an object near the center. This is the object that is that has a density that is the maximum density that we can imagine that matter can have. It's called the Planck density. That's where the curvature of space and time is the maximum, where gravity is as strong as all the other forces in nature. And so I imagine there being an object where the matter collects to the surface of the object as it falls in, and you keep growing that object. Of course, the problem of checking, and I gave a talk about it a month ago, and the problem of checking it is that you have to enter a black hole to see if there is an object there, and it's a one-way trip. So someone said, well, this is not verifiable. I said, well, it's up to you. You can go into a black hole and check it. I mean, I'm not... I mean, it's not as if it's impossible. It's possible. It's just that you will never return to report back about it. And I thought about this idea when there was a flood at the basement of my home. And then I realized that the water that I usually assumed naturally comes, goes out through the sewer, out of the home. I realized that the sewer must be clogged. And we found with a plumber that indeed there were tree roots clogging it. And then I thought, okay, so what happens at the center of a black hole? If it's clogged, then the material will accumulate there. And so that's how I came across this idea, by having the flood in my basement.
Okay.
Oh, wow.
So what are your thoughts then on wormholes? Do you think do you think they're possible to
Well,
do? Do you think?
So once again, we get to a situation where quantum effects and gravity are mixed, and we don't have a good theory of quantum gravity. So at the moment, it's all speculations that people have. And, you know, if you just use Einstein's equations without quantum mechanics, you realize that wormholes, stable wormholes, do not exist. In other words, if you're trying to build sort of a bridge between 2 points in space, that you can traverse faster than light, so that you go from one point to the other faster than the speed of light through this bridge, you find that the bridge is unstable, that it snaps over a time scale that is shorter than your travel time through that wormhole. So according to Einstein's equations, wormholes are not real. But then some people said, okay, well, if we imagine some form of quantum gravity, then we can, in principle, predict wormholes that might exist, made of some material that is very exotic. We don't know if this material exists. So that's where we are. Yeah, people have speculations, but we have no idea if those theories of quantum gravity are correct or if these materials exist. I would say for now, we shouldn't believe these stories.
Okay. And then my last question to you, Will, before you maybe want to ask a couple of things, is what are your thoughts on time travel?
Yes.
Possible?
So,
yeah.
So that's related to wormholes, because the idea of wormhole is that maybe you can travel faster than light, and by that visit your past and do all kinds of you know, some physicists, a very distinguished physicists like Kip Thorne and Stephen Hawking, they argue that most likely there is a ban on time travel, because otherwise you get into some logical inconsistencies. For example, you can take a gun and kill your grandparents, and then how would you exist in that case? It's a logical inconsistency. Yeah. So so other people said, well, maybe if you take a gun and you go back and then you want to kill your grandparents, somehow the trigger, you can't pull the trigger. But so the simplest idea was that, in fact, such trips are banned by physics, that you can't do it. But according to classical physics, without quantum mechanics, it's definitely not allowed. Okay, we have all the experiments as of now indicate that the speed of light is an absolute upper limit. We can't travel faster than light. We can't go back in time. There is no evidence for something like that being possible. But in principle, you know, you might say, okay, well, maybe if we have a quantum theory of gravity and we can build a wormhole, or we can build some other time machine, we will be able to do that. In principle, it's obviously possible, but we have to first develop the theory of quantum gravity and then see what it says. I wouldn't be surprised, since we haven't seen people from the future do things to us as of yet. Some people think, oh, well, maybe these anomalous phenomena that some people report are visits from our future.
Yeah.
But at the moment, obviously, the data does not necessarily say that. I mean, the data is not good enough.
Yeah,
so the bottom line is, most physicists would argue that, well, there is no evidence for that, and also it's probably banned by the laws of physics, but we don't have a quantum theory of gravity to show that.
Okay. And my last question. Sorry, Will. Mm-hmm. If you've got an alien technology that are a couple of thousand years ahead of us, do you think we'll be able to detect in our current technology, do you think we'll be able to detect their technologies? I mean, they may have moved so far over to something else that we would never be able to find it.
Yeah, that's true. Although if you think about a cave dweller from our past, you know, tens of thousands of years ago, someone from a cave touching the technological gadgets that we have, that person should be able to see a cell phone lying on the floor. Okay, that would not be impossible. But then that cave dweller might say, oh, it's a rock of a type that I've never seen before. Okay, Of course, if the cave dweller has a kid, the kid might press some buttons and realize it's not a rock. And so that's why I keep maintaining this kid-like curiosity. The other thing is, when I went to the Pacific Ocean, I asked my students in the class whether, if we find a gadget at the location of the first interstellar meteor and it has buttons on it, should I press a button? And half of the class said, please don't do that. It will affect all of us. And another half said, please do. We would like to see what
happens,
it does. Maybe it's a
better you than
ChatGPT, iPhone 100, whatever. And then a student said, what will you actually do, Professor Loeb? Because the vote appears to be split. And I said, I would take it to a laboratory and examine it before engaging with it. So the answer to your question is, yes, in principle, we could see things even if we don't understand them. For example, you meet people that you don't fully understand, you can still recognize that there are people, they're in front of you. So even though you can't understand some things, you still can identify them as existing. That definitely is the case. However, if they have technologies that are so sophisticated, such that they develop some stealth qualities that do not allow you to notice them. Like, for example, we know that 83% of the matter in the universe is dark matter. It's not visible to us. We know that because we see that this matter gravitates, it creates gravity, but we can't observe it. We can't see it. It doesn't scatter light. It doesn't produce light. So we call it invisible matter or dark matter. That's 83% of the matter in the universe. So imagine those aliens knowing what dark matter is and building a spacecraft out of dark matter. We wouldn't see it in that case. So in that case, the answer to your question is no, we wouldn't notice it.
Just a question that's popped into our mind now, dark matter. I know it's still theory because we don't really know what dark matter is all about, if I'm correct. Would dark matter be affected? Because now you're saying, you've brought something up here. You're saying that it creates gravity.
Right.
Is that not what black holes do?
Yes.
Is it not related? Are dark matter
yeah,
and
that's
black holes
an excellent question. Some people think maybe the dark matter is made of black holes that were formed in the early universe. These are called primordial black holes. Yes, so some people suggested maybe the dark matter is made of black holes, small black holes, they could have the mass of an asteroid up to the mass of the moon, and still be around and we wouldn't notice them. That's a possibility.
Okay, because they suck in light as it goes, doesn't it? The dark matter.
Yeah, so but if they have the size of an asteroid, like the mass of an asteroid, it would be really difficult to detect them, because even if they pass through Earth, they don't produce any detectable signal that we can notice. It's really difficult because they're tiny. They have the size of a proton, and they have the mass of an asteroid, roughly a kilometer in size. So if they pass through your body, they will kill you. But the chance of them passing through your body or through Earth is really extremely small, even over the age of the universe. And even if they were to pass through Earth, you won't notice them. So it's really difficult to detect them. And some people suggested that maybe the dark matter is made of black holes, but there are all kinds of ideas of how to look for them, if they pass through stars, if they deflect light, like you were saying, or if they do something else. It's not easy for black holes between the mass of a kilometer-sized asteroid and the mass of the moon. It's still a completely open question. We were able to rule out the possibility that they are the mass of the sun, for example, because then they would deflect light from stars and we would notice them. The gravitational lensing is the effect of where gravity focuses light. And so if there were black holes of the mass of the sun making the dark matter, we would by now notice them, and that was ruled out. But between the mass of an asteroid and the mass of the moon, they're still allowed.
Okay, cool. Liam, yes, sir?
Well, just to go back to the Dave Grush thing you said earlier. Like, what do you think of that whole story and Dave Grush, and have you had any contact with him?
Yeah, so a month ago, I had a Zoom conversation with him for more than an hour, and he seemed to be very convinced, and he said that he cannot reveal the details because it would put him in jail if based on all kinds of agreements that he signed with the US government. And so for me as a scientist, it's a confusing situation because I can only respond to evidence. You see, people can tell me things and they might believe them very strongly, but that's not convincing because it's just like storytelling. When there is a car accident, you have many people involved and each of them tells you a different story, and even though it's the same event. And when you think about it, FIFA, the World Soccer Organization, they decided in the Women's World Cup in summer 2023 that they make a decision about whether there was a goal or not by asking eyewitnesses, the soccer players or the audience. Instead, they are using cameras, video from cameras, and that's the way science is done. So, as much as he sounds authentic and very convinced, the fact that he doesn't give me any specific clues gives me a pause. And I told him also that it's important for him not to speculate about the relevant physics, because he was mentioning at Congress and in other interviews the possibility of extra dimensions explaining it, or the holographic principle, things that come from string theory. And I told him, these are speculative ideas about quantum gravity. He should not really go in that direction. So he should stick to whatever he knows about the facts. And unfortunately, he could not reveal those details to me. So all I can say is that he's convinced, but I'm not convinced.
Okay.
But
Right.
I would very much like to see the evidence. You see, I'm not saying it's not there. I believe him, but I think in this context, the government is, if indeed it has this information, it's their duty, their responsibility to share it with scientists that would help them figure it out.
Yeah, 100%. Well, what else?
Yeah, and just one last other thing is that I remember growing up, just after the last few years, like with the whole pandemic and everything, like science, like it's become like a religion. Like everybody's like, just trust the science, and science is like, it's a process. Science is a process, and it's also like, as I said, with science is people becoming science is a religion, but it's actually just a process. And it's like, even though we think that sometimes we've come to a conclusion about this is how something really works, it can be proven wrong. Like
Exactly.
Galileo and whatever, and so forth.
And with respect to religion, I wanted to emphasize one thing, that there is this biblical story about Moses in the Old Testament that saw a burning bush that was never consumed. And that convinced Moses that God exists. And what is God? It's a superhuman entity. But today you could buy off the shelf an object that will not burn like a bush and put it in front of Moses, and he would be amazed and filled with awe. So if I was next to Moses, I would use an infrared camera, measure how much energy is coming out per time out of this bush, measuring the temperature, and telling Moses whether it was constructed by a superhuman entity. But this superhuman entity, instead of calling it God, it could have been just a more advanced scientific civilization. So my point is that, if we meet someone that is far more advanced than we are, we might be filled with religious awe. And it's a way of unifying religion with science, because there will be something real you are encountering. You look at something and it looks like a miracle, but it's actually a much more advanced technology. That's all.
Mm-hmm. Yeah, we've got the same thoughts. I mean, we not that we have it yet, but the Anunnaki, all those kind of things, the discussions in Sumeria about the so-called gods, we've all kind of figured out that they've actually been advanced civilizations that have been there before us.
Yeah, and that's why I think it's advantageous for us to meet with them, because it's like meeting a smarter kid in your class. You know, you can learn from them, and that will give us a glimpse at our own technological future, and maybe encourage us to do better and to change our priorities. Because right now we are, look at the world news. Much of it is about hostilities that, some people want to kill other people. It's such a narrow-minded and stupid thing to do when you think about the universe at large. We are all sharing this rock that we were born on, the Earth, and we keep fighting with each other about territories where there is so much real estate in space, and the universe is so big, and it's completely ridiculous that we are doing what we're doing. But maybe the wake-up call will come from us noticing that there is a neighbor out there.
Yeah, that would be fantastic. And I know, I wish you the best of luck in your project. Seriously, I hope you find technology out there that would be awesome for us lay human beings to hear those things coming through.
Thank you.
It'd be awesome.
That's my hope. My hope is during my lifetime, within the coming years, to find it, and then I would say that my life was worth living.
Yeah, that would be fantastic.
Well, yeah,
Will, anything on your side, bud?
No, we just want to say I really appreciate the work you're doing in the Galileo project. It's very exciting to see, someone in a proper scientist, taking this kind of stuff seriously. So it's a breath of fresh air. So thank you very much.
Thank you so much. And there is a filming crew that is following me, producing a documentary for Netflix. So hopefully it will come out in a year or so.
Oh,
So
wow, that's fantastic. Jeez, I can't wait to see that.
And there is also a playwright that wrote a play. He wants me to perform it off Broadway about my research. And there is also a sculpture that makes a sculpture that just 2 days ago I got a phone call from Germany. Someone made an art based on what I'm doing. So people are inspired, but it's not easy, to do all this work, and I'm doing my best.
But I think what's important is that people are taking notice. And when more people take notice, the more interest you have in the subject that you are trying to do, and hopefully more finance comes your way so that you can do more with what you need to do.
Yeah, I really hope that more people will behave like kids, just being curious, wondering, not so much attached to their ego, and there will be world peace at that point, hopefully.
Yeah, that's
Hopefully.
like the Hermetic saying, assume nothing so you can know everything.
Yeah,
Exactly.
100%.
Exactly. Yeah.
No, awesome. I don't know if there's anything from your side, but yeah, thank you very much for coming on and for spending your time with us. I know did you do your 5-mile run this morning? 5 mile.
Yeah, I did. I do it every morning at sunrise. I did it also on the ship in the Pacific Ocean, and except that the documentary producer said to me, "We want to film you one morning," and then they asked me to run 10 miles that morning instead of 15 miles. But I survived that nevertheless. Yeah, because it brings me closer to nature. I'm jogging on my own and without any people around. Everyone is asleep at that time. And also every sunrise is different in terms of the colors and being surrounded by animals. And it's just, cannot be better than that. Much better than the rest of the day for me.
But I think it's also the time that you're in your own mind. So how long does it take you? How long does it take you to run your farm?
About half an hour, and then as you are exactly correct, because I then think about everything that happened the day before and what I would like to do in the next day, and it's an opportunity for processing. That when you are engaged in answering emails or answering phone calls and speaking with people, you just don't have that luxury of processing what happened to you. And so it's good to have time for yourself, at least half an hour. I highly recommend.
And especially for your work, because you probably get all your great breakthroughs then as well.
Well, it's your meditation time, isn't it?
Yeah, it is meditation. Exactly. It is, but a different type while exercising. Yeah.
Yeah, 100%. No, awesome. Avi, thank you again so much.
Yes, thank you. Thank you so much.
Yeah, thank you.
My
Avi.
pleasure. My pleasure.
Thanks. Cheers.
Bye-bye.
Cheers. Bye.
Okay. Cheers, man.
Thanks.
So I'll never think of athletics the same again. I mean, I really thought athletics was pointless, but like when he said it, it just sounded even so much more pointless. I was like, geez,
Yeah, it's like, why are you doing it? You know, no, but just clever guy, very very understanding, and you know, it's always good to have you know, people like that, especially like I was saying, on our side of the fence. I mean, we always the one that believe in extraterrestrial life, or believe in something else that's there, and it's lucky to have scientists that really are kind of on our side of the fence now.
yeah,
You know, not on the other side, which I think is absolutely so necessary, but because we'll never move forward, we got to keep having this division. And until such time as you've got people like Avi that can actually start researching certain things and then coming back to the public and saying, yes, actually, this is what we found. We found
Yeah.
some sort of technology, and that'll blow the lid off everything.
yeah, I know. I
You know
mean,
what I
that's as you said, like, yeah, because you can't think outside of the box anymore, because then the mainstream narrative just shuts it down. So we never can actually progress, because we just trapped in this like one way of thinking, and this, and you
Yeah,
know,
and it's a constant battle between the two. You know what I mean? It's like ridiculous, man. But
yeah,
when you've got guys like Avi, and I'm assuming there's a lot more, you know, trying to figure out and do what they can to find out what's really actually happening and what's really there. It's just, yeah, I think it's awesome. I think
no,
it's
it's really
something
great.
we need, and it's a good way forward, especially for our time, man.
Yeah, man.
Well, guys, thank you for listening again today, and thank you for your time. Hope you support and follow us. Again, thanks for your time, guys. I know it was a little bit long tonight, which is great. Thanks for Avi for coming on. Will, thanks again for your time.
Yeah,
And
thanks.
yeah, we'll speak to you guys next week. Cheers, guys.
Cool, man. Cheers, man.